In section 4.4, I will be going over solving exponential and logarithmic equations. I will be doing a handful of examples in this video. Please make sure you go to the Canvas notes to see more examples. So let's take a look at the first one. Let's solve 2 to the x equals 8. One way of solving an exponential equation is make the left-hand side and the right-hand side look like exponentials. So on the left, it already is an exponential form. So it's 2 to the x. On the right, we can make 8 2 to the something. So let's think. 2 times 2 is 4, times 2 is 8, so that's 2 cubed. And now, if the bases are the same, you can ignore the bases and set the exponents equal to each other, and we're done. Alright, but let's take a look at the next example. 4 to the x equals 5. Now, on this problem, there's nothing we can do to make the 4 and the 5 have the same base. On the previous example, it was nice and easy. I could make the bases both 2. But for this one, it's not possible to do that. So, in order to solve for x, I need to remove x from the exponent position. And to do that, we have to use the power log rule. So before we do that, we have to have logarithm in our problem. So first thing we do is log both sides. So it's going to say log 4 to the x equals log 5. Remember, we can do that in math as long as I do the same thing to the left and to the right, it's still fine. Now I can use that power rule. The x comes out front and multiplies with log 4. And now we're almost done. X and log 4 are multiplying each other. To move log 4 to the other side, I'm going to divide. And so, final answer, x equals log 5 over log 4. No need to simplify or do anything extra. You can leave your answer like that. Alright, let's try a little bit harder now. Again, I have 3 raised to the x minus 5 equals 2 to the 4 minus x. Again, there's nothing we can do to 3 and 2 to make them have the same base. So we're going to go ahead and log, or we can ln. Let me show you. You can get the same result. Remember, ln and log have the same exact rules. Alright, power rule next. Alright, and now it looks a little squishy and confusing, right? X minus 5 ln 3. So for clarity, it's really important to make sure you use parentheses around everything that was in the exponent position. Perfect. Now remember, ln 3 and ln 2 are just numbers, so it's also kind of like glue. Make sure you never separate what you're taking the ln of. Alright, now it's multiplying, so favorite D word, I have to distribute. So this is x ln 3 minus 5 ln 3 equals 4 ln 2 minus x ln 2. Now we're solving for x, so we need to get everything with an x on one side of the equation and everything that doesn't have an x to the other. So I'm going to do 2 steps at once. I'm going to add x ln 2 to the left. And I'm going to add 5 ln 3 to the right. On the left, I have x ln 3 plus x ln 2. Those aren't like terms because I'm ln'ing something different. So I just have to write it side by side next to each other, like so. And then on the right again, not quite like terms, so everything just gets written side by side. Alright, so we did this concept earlier when we were taking or finding the inverse of certain functions. Alright, if I'm trying to solve for x and I have x in 2 different places, to write it once on my paper, I'm going to factor. So GCF, I'm pulling out an x, and I have ln 3 plus ln 2 left over. Nothing is happening on the right yet, so everything comes down. Now again, x and ln 3 plus ln 2 are multiplying. The opposite of multiplying is dividing. And same thing on the right hand side. Cancels out on the left, and I'm left with x equals 4 ln 2 plus 5 ln 3 all over ln 3 plus ln 2. Once x is by itself, you can leave your answer exactly like that. No need to use more log rules to simplify it. This is perfectly fine for me. Alright, let's try something a little different. I have log base 2 of x minus 1 equals 2. To solve this one, instead of writing logarithmic form, I'm going to transform this to exponential. So this is going to say base 2 is this 2, raised to the 2, which was this 2, is equal to x minus 1. 2 squared is 4. Add 1 to the other side, and final answer is x equals 5. Always make sure you do a double check that the number you get works within the domain. So if I plug 5 back into here, 5 minus 1 is 4. That's a positive number. It checks out and you're good. And one last example. Let's solve log base 2 of x plus log base 2 of x minus 7 equals 3. First thing we need to do is condense the logarithm. So 2 logs adding is going to become multiplication. So that's log base 2, bracket for clarity, x times x minus 7 equals 3. Now convert from logarithmic to exponential form. That's 2 cubed equals x times x minus 7. Simplifying, 2 cubed is 8. Distributing, I get x squared minus 7x. Now I have a quadratic, so set it equal to 0. So subtracting 8 to the other side, 0 equals x squared minus 7x minus 8. Now again, as a reminder, 4 ways of solving a quadratic: factor, complete the square root method, or quadratic formula. I believe this particular example is going to factor nice and easy. 2 numbers that multiply to negative 8 and add to negative 7. That's going to be negative 8 and positive 1. Setting each expression equal to 0. Solving for x, I get x equals positive 8 and x equals negative 1. Now remember, let's do a double check and make sure it works in the domain. So I got 8 and negative 1. If I plug 8 in here, that's a positive number. If I plug 8 in there, 8 minus 7 is 1, also a positive number. 8 checks out, no problem. But what happens when I plug in negative 1? I have log base 2 of negative 1. I cannot take the logarithm of a negative number. So guess what? Negative 1 does not work as a solution, but 8 does. So this particular problem has one solution at x equals 8.